Greetings everyone. Today we're going to explore the real number system. For these notes, you will need this foldable. Now, we've likely put this together in class already. If you have not, you might just consider jotting these notes down in your notebook. The papers are available online on Google Classroom, and there's also a video that shows how to put it together. So, for the first set of notes, I need you to turn to the very bottom of that foldable, meaning flip everything up to the very bottom. When you get to the very bottom, you should see real numbers definition. So what are we talking about here? Let's write the definition. What is a real number? Real numbers are positive or negative, large or small, whole numbers or decimal numbers. Now this part's going to sound funny. They're called real numbers because they're not imaginary? Imaginary is something you'll learn more about later on in math. But for right now, we really need to understand that real numbers encompasses all the numbers we'll deal with in this class. Remember, at any time, if you need to pause to write things down, please do so. All right, on that same foldable, you want to take the next tab down and you should see the word rational numbers. It's a square that has space with rational numbers, a space for definition and examples. So make sure you're on the right piece. If you're writing in your own notebook, just pause this video and jot this down. The definition of rational means any number that can be written as a fraction. Or I like to think of it as you can write it cleanly. So a fraction would look like 2/3, right? If I looked at 2/3 as a decimal, it's repeating, it's 0.66. Well, that's rational. I could remember that. So here's my little tip. It's rational if you can remember. Hear that R sound? Another example is any whole number like 7 or integers like -18. If it's a decimal that ends like 0.49, I could remember that. That's easy. Or a repeating decimal like 0.7 repeating. I could remember that. So rational means you can remember it. Oh, let's jump to the right side of that notes sheet. See how you have that skinny column off to the right? You'll notice it says irrational. Okay? Irrational. Think if someone's irrational. If someone's irrational, they make no sense, right? It's not someone that I can work easily with. So the definition of an irrational number is a non-terminating and non-repeating decimal, right? Meaning it doesn't cut off, it doesn't repeat itself. It's messy. Another way you could write it down is it can't be written as a fraction. Or in my mind, if rational means I can remember, then irrational means I can't remember. So some examples. Square root of 3. If you type that into a calculator, it gives you some crazy, never-ending decimal. I could never remember that decimal. Or pi, right? We can remember some digits of pi, but pi goes on in no pattern forever and ever. It makes no sense. It's irrational. So rational means I can remember. Irrational means I can't. All right, let's jump back over to the left side of your notes. Alrighty, let's go back to the left side. We're going to bring the next tab down. So flip your flip book until you see the word integers. Or if you're writing on your own notebook, just jot this down. Integers. Integers include positive or negative whole numbers and 0. So here's Here's my trick as you jot that down. Here's my trick to remember this one. Integers are number line numbers. Think of the number lines that your teachers used to tape on your desk, right? Or number lines that we have on our marker boards. Integers are number line numbers like -5, 7, 2, -1, 0. If you're a visual learner, you guys, integer starts with I. If I turn that I sideways, it looks like a number line. Integers are number line numbers. All right, let's look at the next tab on your foldable. Look for the title, Whole Numbers. The definition is whole numbers includes all natural numbers and 0. All natural numbers and 0. So what does that mean? I remember this one if I can put, meaning whole means an item, right? Like let's use cars. Can I have 3 cars? Yes. Can I have -5 cars? No. Can I have 0 cars? Yeah, that's a true statement. Can I have 10 cars? I wish, right? If you can put an item, it's a whole number. So under examples, please jot down 0, 1, 2. The ... of course, means it continues in that direction. All right, flip to the next tab. We're all the way to the top of that foldable. We're looking at the phrase natural numbers. Natural numbers are the numbers you first learned as a kid. So it includes numbers you naturally count with and that occur in nature. So think of the very first number little kids learn. It's natural for little kids to say, I'm 1, and then they turn 2, and then 3, right? The first numbers you ever learn, it's natural for you to learn them. You learn 1 and beyond. Easy, clean numbers. So under examples, make sure you draw 1, 2, 3, ... When we look at this concept, we want to think of it like these nesting dolls. One category lies in the next, in the next, in the next. So real numbers on your foldable contains all of them, right? Every number we deal with in this class is a real number. And then we can take a look and say, well, rational numbers includes integers, whole, and natural, but not irrational. See how that foldable allows me to visualize what categories within which? All right, for this part, you do not need to write this down. But this sort of looks like your foldable, right? We're going to categorize some numbers. So the first thing I want to do is I want to look for irrational numbers. I think that's the easiest. What numbers are crazy and I couldn't remember them? Well, let's see. I see this 8.23017 ... That means that number goes on forever. So I don't know what it is. I can't remember that. That means it's irrational. If we look at our notes, we know pi. Pi is a crazy number that goes on forever. It's irrational. We might need our calculator here. Square root of 2. If you type that into your calculator, you get 1 point something, 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 something. I don't even know what it is as a decimal. That means it's crazy. It's no good. It's irrational. It's hard to work with. And you might be thinking, well, there's another square root of 9, but if you type that in your calculator, that actually equals 3. So that's an okay number. Let's see, all the other decimals, I could remember those. They're repeating, they're easy to think of. All right, let's jump to the other side. Let's start on the innermost category, natural. Kids naturally learn 1, 2, 3, 4, 5. So let's find the numbers that kids naturally learn. They naturally start at 1. They learn 2. I see a 3. 4, 5. I see a 5. It's natural for kids to know those numbers. Now, those 3 numbers are also whole numbers, but what else is a whole number? What else can I have Ooh, you guys, I forgot one. Oh, square root of 9. If square root of 9 equals 3, then that means it is a natural number. I need to make some room here. 3 is a natural number. So even though square root of 9 looks messy, its actual value is 3. All right, sorry, let's jump back to whole numbers. Whole numbers means I can put a label after it. Always think cars, right? So can I have 0 cars? Yep, sure can. Can I have negative cars? No. 0.73 cars? Nope. Let's talk about the 75/15ths. I feel like if we divide that, it might work out nice and clean. Okay, so let's get your calculators out if you haven't already. Let's try it out. If you take 75 and you divide by 15, you get 5. Oh, that's kind of a clean number, right? So I'm going to make this a little smaller. And that's actually a natural number. It's natural for kids to know 5. So if you can simplify, you need to. So look at my natural numbers. 1, 3, 3, 5, 5. Whole numbers includes 0. Integers. Integers are number line numbers. Well, negative 100 would be on the far left of my number line. And then I'd get to a negative 18 on my number line. And then I'd have a negative 6 on my number line. It's a big number line, but they're all on there. Now the rest of these, those wouldn't be on a desk number line, right? So if you look at this integers square, let's say, I'm going to kind of put a square around it. If you take a look at that square, let's see if I can make this a little more faded. Bear with me. Oh, can I not do that? Oh, goodness. Okay, so if I look at all the numbers in this square, though, right here, okay? See how I'm moving that around? All of those numbers are integers, right? 5 is an integer. 3 is an integer. 0 is an integer. Negative 18 is an integer. See how that box contains every number within? That's like those nesting dolls. All right, rational. Rational means I could remember it, but it might be messy. So I could remember 2.73. I could remember any fraction, because fractions are really just 2 numbers above each other. I could remember 3.8, and I could remember 5.4242424242. Right? So when we're categorizing, start with irrational. Get rid of the crazies first, right? Then I like to start with natural. Is it natural for a little kiddo to know that number? Make sure you simplify if needed. We'll keep working on this. We're going to have some assignments where you will have to take care of numbers like this, and you will have to use your calculator and divide it down or square root. Okay, so keep an eye out for those. All right, another way that we're going to identify is if I give you a number, I'm going to have you list all of the categories it fits in. So our first thought is going to be, is it real? Well, here's a hint, you guys. Every number I'm going to give you is real. That's your freebie answer. And then you're going to decide, well, is it rational or irrational? They're opposites. So could I remember it or could I not? So let's start off with negative 4/5. It's definitely real. Every number on here is real. So you would write real, 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 real. Then I would say that it's rational. I could remember 4/5. Then I'd decide, is it an integer? Is it on my number line? Nope. So guess what? We're only going to write down rational and real. All right, let's look at negative 9. Negative 9's real. That's your freebie. Is it rational or irrational? Oh, I could remember that, so it's rational. Is it on the number line? Is it an integer? Yes, it is. So it's an integer first. It's also rational, and it's real. Square root of 16. Well, guess what? If you plug that in your calculator, you guys, it's actually 4. 4 includes all of them because it's natural for a kid to know the number 4. I could have 4 whole cars. 4 is on the number line. and I could remember 4. And your freebie answer, every number's real in this class. Let's look at negative square root of 25. Negative square root of 25. Well, square root of 25, plug it in. It's actually 5. Okay, so if I have a negative 5, is it natural for kids to know negative 5? Nope. Could I have negative 5 cars? Nope, so it's not whole. Could I have negative 5 on a number line? Yes, it's an integer. Could I remember negative 5? Yes, it's rational. And all numbers in this class are real. Let's look at number 5 there. Square root of 8. If you plug that into your calculator, it's a crazy decimal. Let's see, for example, it looks like it would be about 2 point something, 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 right? Well, it's not natural for little kids to know that. Can't have square root of 8 cars. Square root of 8 or 2 point something, something, something is not on the number line. I couldn't remember that. I don't remember that. I'd have to use my calculator. Therefore, it's a crazy number. It's irrational. And your freebie answer, even though it's a crazy number, it's still real. All right, as always, check Google Classroom to see what your task at hand is. If you need help, make sure you ask questions. Let me know how you're doing. And until next time, have a good one.